Hello students and welcome back to my channel. We are discussing questions which were asked on the 1st of February 2023 JEE Mains. So in continuation with other videos, I am posting this video, student. Okay. So let us continue. This question 40, the other questions you can look into other videos. Find the magnetic field at the point P in the figure. The curved portion is a semicircle connected to two long straight wires. You can see the figure, students. So this is infinitely long and this is also infinitely long. You have to find the magnetic field here. So as I usually suggest students, always see you have only two kinds of wires, straight wire and circular wire. Formulas for them we all know. So just number the straight portion as 1, the semicircular portion as 2 and the other straight portion as 3. This will be your first step. Go on numbering the different straight portions and the circular portions, and then write down the formula for magnetic field due to each portion there vectorially. You have to be very careful because V is vector quantity. As per the directions, you have to add them. You have to obtain the result. So I'll write B1. What is B1? You see, if you drop a perpendicular from here, so this wire 1 is a semi-infinite wire. We call it as a semi-infinite wire because when you drop a perpendicular onto the wire, the foot of the perpendicular lies exactly at one end, the other end is at infinity. Such situation is known as a semi-infinite wire. So we have mu 0 I by 4 pi r. This is the radius of the circle. Okay. And as per the direction, we all know that it is along the upward normal to the plane of the page. Okay. What is the concept? I told you several times that use your right hand, stretch your thumb in the direction of current and take the tip of the finger towards the side where you require the direction of magnetic field. So the tip of the fingers, the remaining 4 fingers, will point in the direction of magnetic field. Again I am repeating, students. Stretch your thumb in the direction of current. Take your fingertips, the remaining 4 fingertips, towards the point where you require the direction of magnetic field. Okay, and position your hand like this. So this fingertips will point in the direction of magnetic field here. Then B2 is magnetic field due to a semicircular wire. So half that due to a complete coil. Complete coil it is mu 0 I by 2r. Okay, and this is also directed along the outward normal. And you can see B3 will be 0 because after all the point lies on the axis. When the point lies on the axis of the wire, B is 0. So now you can see B1 and B2 point in the same direction. So net magnetic field can be obtained simply by adding them. So just add them, students. So mu 0 I upon 2r can be taken common, I guess. Is it? Yes, because all the options have 2r in the denominator. You can see 2r. So I'll take 2r common. So here we will be left with 1 upon 2 pi and here we will be left with 1 by 2. Okay. So D option is the correct answer. D option is the correct answer. See. Right, students, moving on to the next question. A coil is placed in a magnetic field such that the plane of coil is perpendicular to the direction of magnetic field. The magnitude of magnetic flux to a coil can be changed. Now suppose this is a magnetic field and this is a coil. The magnetic field is like this and the area vector of the coil makes an angle theta. So what is the magnetic flux associated with this coil? So magnetic flux associated with the coil is the NAB cos theta, where N is the number of turns. There can be more than 1 turns. Okay. You can see flux depends on all these conditions. So we can change the magnitude by changing the magnitude of magnetic field. Of course, if we change the magnetic field, flux will change. So this is true. By changing the area of coil within the magnetic field, yes, this is also true. Then by changing the angle between the direction of magnetic field and the plane of the coil, yes, if theta changes, then certainly B will change. Then by reversing the magnetic field direction abruptly without changing its magnitude. If we reverse, then certainly what will happen? Instead of theta will become theta plus 180. So cos theta plus 180 is minus cos theta. So the value will remain same, but sign will change. But we are interested in the magnitude. So the magnitude of magnetic flux through a coil can be changed. Here magnitude will not change. So this is the only situation in which things are not working. We require the magnitude of magnetic field to change. So magnitude will not change, only the sign will change here, because cos 180 plus theta is actually minus cos theta. So A, B and C are the correct options. So C option will be the correct answer. Then moving to the next question. As shown in the figure, a long straight conductor with a semicircular arc of radius this much is carrying a current this much. The magnitude of the magnetic field at center row of the arc is. Again, student, as I told you just now, I suggested, just mark the different straight portions and the circular portions. Okay. Then B1 and B3 will be 0 here. Remember, we have to find the magnetic field at point O, because point O lies on the axis of these two wires. So magnetic fields will be 0. We are left with only B2. Okay, due to semicircular wire, it is half into magnetic field due to a complete coil. Due to complete coil, it is mu0 I by 2I twice R. So this should be the answer. So half into half, mu0 is straight away given as 4 pi into 10 to the power minus 7 SI units. Current is 3 amperes and the radius is pi by 10. So pi upon 10. So let us cancel 4 pi gets cancelled. Then we are left with 3 into 10 to the power minus 7 plus 1 is minus 6 Tesla, which is 3 micro Tesla. So correct option is the A option. Moving to the next question. A charged particle of 2 microcoulomb. I'll just adjust the size, students. Slightly it is enlarged. Yeah, now it is. Yeah. A charged particle of 2 microcoulomb accelerated by a potential difference of 100 volt enters a region of uniform magnetic field of 4 millitesla at right angles to the direction of field. As we all know, students, when a charged particle is projected at right angles to the magnetic field, it will go along a circle. So the charged particle completes a semicircle of radius 3 cm inside the magnetic field, the mass of the charged particle. So we are being informed regarding the radius. So try to note down the formula for radius. Okay. See, suppose you have a magnetic field like this. If you have a magnetic field directed into the plane of the page, then the particle will enter at one point and exit at the other point. Okay, so suppose it enters like this with the speed v, it will exit with the same speed v, undergoing a semicircle of radius r. So charge is q, mass is m. We all know that radius is mv by qv. This formula can easily be obtained, students, by equating the magnetic force with the centripetal force, because in order to go along a circle, any object would require centripetal force directed towards the center, and that centripetal force is provided by what? By the magnetic force, okay, which we also call it as Lorentz force, Q into T cross B. So equating these two, you get this result. Now instead of giving an information regarding speed, they have told that the charged particle is accelerated through a potential difference. So when that be the case, then this momentum can be replaced with under root 2m into kinetic energy. We all know from mechanics, momentum is this. Also, in case of a particle which is accelerated through a potential difference, the kinetic energy gained is charge multiplied by potential difference. Okay. So therefore, we can write like this: under root 2mv. I have taken q inside the square root is equal to dr. So now it's a matter of formula substitution. We'll be able to find m here. Okay. So let us substitute the values here. So here itself I will substitute. Mass is, we have to find the mass. Voltage is 100 volt. So 100 volt. Charged particle is 2 microcoulomb. So 2 into 10 power minus 6 is equal to B. Magnetic field is 4 millitesla. So 4 milli is 10 power minus 3. Radius is 3 centimeters. So 3 into 10 power minus 2. So we have substituted all the parameters in SI unit. So let us solve this. So here you can see 2 gets cancelled here. Okay. So we are left with root over m into minus 6 goes up becomes plus 6. So 10 to the power 8. 10 power 8 is equal to 12 into 10 to the power minus 5. Minus 3 and minus 2. Now squaring both sides, we have 10 power 8 m is equal to 144 into 10 to the power minus 10. 10 power minus 8 goes that side to become 10 power minus 8. So 10 power minus 10 and minus 8 is 10 power minus 18 kilogram. Of course, we can expect the answer in SI unit. So the correct answer is 144 into 10 to the power minus 18 kilograms. Then coming to question 44. A square-shaped coil of area 70 cm square having 600 turns rotates in a magnetic field of 0.4 Weber per meter square about an axis which is parallel to one of the side of the coil and perpendicular to the direction of field. If the coil completes 500 revolutions in a minute, the instantaneous EMF when the plane of the coil is inclined at 60 degrees. So as soon as you read the question, student, this figure should immediately pop up into your mind. So magnetic field is like this, and you have it is rotating about this one of the edges perpendicular to the magnetic field. So this is the area vector, and you have theta. So we have to find the instantaneous EMF. Before that, we can find the flux. So magnetic flux linked with that is NAB cos theta. Okay. Number of turns into A into B into cos theta. So NAB cos theta. Now induced EMF as per Lenz's law is minus d phi b by dt. So as you differentiate with respect to time, you have NAB sin theta d theta by dt. D theta by dt is omega. So this is the final expression. So we have to substitute the values here. Okay. So let us substitute the values here. Number of turns is 600. So 600. Then area is 70 centimeter square. 70 centimeter square to be converted into meter square. The magnetic field is 0.4. 0.4 is 4 by 10. And sine. The plane of the coil is inclined at 60 degree. Try to understand, students. This is the plane of the coil. Plane of the coil is at 60 degree means theta will be 90 minus 60, that is 30 degree. At sine 30 degree is half. So this should give you the answer in volt, because we can expect the answer in volt. We have substituted all the parameters in SI unit. So once 0 gets cancelled here, then we have 2 2s are. So 6 7s are 42 into 2. We have to we have missed omega. Omega we have to substitute, students. First let us write the value of omega here. Omega is 2 pi f. it executes 500 revolutions in 1 minute. So omega will be 2 pi into frequency. Frequency is 500 revolutions per minute. So upon 60 seconds into sine 30 degrees half. Okay. So this 2 2s gets cancelled here. Then we are left with what? Let us calculate quickly. Let us separate the figures. We have 6, then we have 7, then this 2 and 2 are there. So 4 is there. Pi is 22 by 7. Okay. Then this 2 zeros and 2 zeros are 4 zeros. 10 plus 4 and 10 power minus 4 gets cancelled here. And we are left with 1, 5 and 60. Okay. So 6 tens are 7 7 gets cancelled. 5 twos are 2 twos are. So finally we are left with 44 volt. So 44 is the correct answer. You have to be very careful, students, with the calculations. A slightest mistake will land you in the wrong answer. So you have to be very careful. Okay. That's all, students, in this video. Thank you so much for watching my channel.